that Professor Castellina just is coming to the Lomonosov conference, and we are waiting for your review talk on behalf of Piaget.
Well,
You're
it's on behalf.
one of the
I'm
top
one of
leaders.
the two spokespersons. Yes,
Yeah.
yes.
It is a great honor for Lomonosov conference.
Thank you very much.
This famous world experiment is presented on the highest level at the Lomonosov conference. We are proud of this. Thank you for coming.
Thank you to
and,
you.
I would like to ask you just the day before your review talk, what is the more important issues now you're considering, and what are your expectations?
Well, you know, in the ultra-energy cosmic ray field, the most important question still remains the one of finding the sources, because, as you know, we have been hunting for the sources since a long time, and in the last 10 or 15 years there was a really, really big revolution in detectors and precision, accuracy, and also exposure of the detectors. So we hope that we will be able in the near future to find a way to reach an answer to this question of the sources. And then, of course, this implies to study the energy spectrum and the composition of the primary particles, which indeed is together with the anisotropy measurements, are the three pillars on which we base our study. So this is our main aim, and you may know that both the two main experiments in this area, which are the Piaget Observatory and the Telescope Array, they are all both going for an upgrade, different kind of upgrades, but this will help in the field a lot to reach this answer.
And have you chance to feel that's the influence of neutrinos somehow? I mean, it's multi-messenger
yes,
approach.
in Auger in particular, we are able to measure neutrinos. We are mostly sensitive to neutrinos at 10 to the 18 electron volts, so very high energy. So these are cosmogenic neutrinos produced by interactions of cosmic rays with the cosmic microwave background. We at the moment have, together with IceCube, the best limit to cosmogenic neutrinos, and as I will show tomorrow, we have also the possibility now to exclude few models of sources, particularly those that pertain to proton accelerating sources. So we are giving our contribution. And also with our neutrinos, we are able to follow transient sources. So for example, last year we had this very famous gravitational wave event in August. And we were so lucky to be exactly in the right place in the sky with our exposure with tau neutrinos. So we could give also upper limits to the production of ultra-energy neutrinos in coincidence with the gravitational wave, which of course it's a limit which is still quite high, but we are the only one that can put it at this energy. So in any case, it's very important because we are the only one that can test the models for this kind of neutrinos from gravitational wave events, particularly neutron star mergers. For black holes, it's more difficult because we would need particularly precise conditions in the source to have neutrinos from black hole mergers. Yeah.
Well, thank you very much, and we are waiting for your talk.
It was a pleasure. Thank you.
Thank you.